So basically, this is the look of our model. To execute this model on Arduino, I had to divide this model into 10 parts. The code I wrote loops 10 times, and each time it loads only necessary constants for each part. For example, in its first step of repetition, it loads the input image, first kernel, and bias. But bias isn't in the form of matrix. Bias is loaded already flattened. Then multiply kernel values to image pixel values, and I added those values directly to bias. Now I have flattened array of convolution layer. Then I applied ReLU activation. The full flattened array's length has to be 5760 in this model, but since I only loaded 10% of the model, I get to have an array length of 576. So in this case, to calculate two values of final result, we need only 1152 values, but loading 1152 values in one array is quite impossible in Arduino. So I just loaded two values every single time and looped 576 times. And we add the values to the global array. Since we have only executed 10% of all things, we should not apply activation to the global array yet. After having all 10 loops, then apply softmax activation, and you print the result, then you can see the prediction. Here's the real-life footage of this model running in Arduino. Arduino is hooked up to an SD card which includes weight and image. If you're not sure if this is not fake, perhaps you should try it for yourself. You can get some ideas in my GitHub link in description.